Hello, this is Miss Van Human here, and today you guys are going to be completing your second workshop on solving simultaneous equations. Today you're going to be using the substitution method. So in our previous workshop that we did on Monday, we learned how to solve simultaneous equations by graphical methods. Remember that a linear equation is a straight line graph, and when we graph two of those linear equations, the point where they intersect, that coordinate, so like 1, 2, that is the solution to a set of simultaneous equations. This method clearly has its limitations. It was really slow and tedious in practice. It was also difficult to accurately draw graphs. You had to be really careful with your rulers, and this was particularly shown when you didn't have integers as exact solutions. So if you ended up with a decimal or a fraction. In the next two workshops, so today and next week, we are going to go over the two algebraic methods called substitution and elimination that we use to solve simultaneous equations. So your learning intention for today, we are learning to solve simultaneous equations using the substitution method. And why we're doing this is because algebra is used to help solve complex problems in real life. And we're doing this through a workshop, notes, and skills practice with the exercise if you get up to it. Now, you might have noticed already that I don't have Mr. Carter's iPad with me today. I'm just using the PowerPoint slideshow presenter, so you don't need to hit the spacebar to keep going. It will just go through and skip through the steps as I speak with it, so you're better off just to pause it and listen to it as you go. Alright, let's get started. So workshop 2, solving simultaneous equations using substitution. Make sure you have your page ruled and you write this heading down in your book with today's date. So there are two algebraic methods called substitution and elimination for solving simultaneous equations. The substitution method involves a pronumeral, so our x or y, being replaced or substituted by an expression involving the other pronumeral. And I'll show you what this means. So we use substitution when one of the equations has x or y as the subject, e.g. it's in the form down the bottom here. You'll see that the x equals 2y plus 4 or y equals 7x take 3. So both of those linear equations have x or y as the subject, so it doesn't matter which one is by itself, but we've got an x equals by itself or a y equals by itself, and that's when we use substitution. In this exercise, you'll only be using substitution to complete solving these equations. Alright, let's have a look at an example. So example 1 says solve this pair of equations for x and y, and we have our pair of linear equations. Now this suits what we just spoke about because both of these equations are in the form y equals, so they both have y as a subject. Now in the corner down here, you might like to pause the video and copy out these steps for solving simultaneous equations using substitution. You don't have to, but I expect that you copy out the example and all the working out to go over in class on Friday. So let's go through these steps. Step 1 says label the linear equations 1 and 2, and we literally do that by drawing a straight line and labeling it equation 1. And and equation 2, another straight line there. Now we need to decide which equation we're going to substitute in the other. So we're looking for that x equals or y equals. We're starting off with an easy example today because these are both in the form y equals, so it doesn't matter which one we substitute into which equation. So what we're going to do is substitute 1 into 2. So what I've done in these brackets over here, you don't need to copy out this brackets in the blue with the yellow. So I've just highlighted in the yellow that 2x plus 1, that is y, and we're going to substitute that and replace it for the highlighted y in that second equation, y equals 3x take 2. So let's have a look at that. Okay, so you need to copy this working out here. So I've written in 2x plus 1, which was 1, the equation 1 y equals 3x take 2. Okay, what we need to do is collect our like terms on the one side. So I need to get all the x's over the one side. So it makes sense to take 2x from each side so that we end up with a positive x. So we're going to take 2x from each side, that cancels out, and we're left with 1 equals x, take 2. Now we want to get that x by itself, so we're going to do the opposite to what's on the side with the x, which is adding 2 to both sides, and that minus 2 plus 2 cancels out, so we're left with x equals 3. So now we're up to step 4. We need to substitute the known variable back into one of the equations to find the other variable. So we know that x equals 3, that's half of the coordinate for our solution. We need to sub it into equation 1. Again, it wouldn't have mattered if we used equation 2 to find out what y equals. So we sub x in, so y equals 2 times 3 plus 1, which equals 7. So we need to state our solution as the coordinate 3, 7, which is where those two linear equations intersect. Now, we need to also check our solution using substitution. So if we check the first equation, substitute in the x value, so y equals 2 times 3 plus 1, and that equals 7, so yes, that's correct. And our second equation, y equals 3 times 3, which is 9, take 2 is 7, so yes, that's also correct. Okay, example 2. Solve this pair of equations for x and y. So this time, you'll notice with our two linear equations that one equation is in the form y equals and then the other one isn't. So again, we label our two equations 1 and 2. And this time we have to substitute equation 1 into 2 because it is the only equation that has a pronumeral, so x or y, as the subject. So let's sub 1 into 2. So I've just highlighted it again there for you. And this is your first step of working out. So I've just replaced that y with the subject of y in equation 1. So our first step here is to follow BODMAS, and we need to expand our brackets. So 2 times 2 gives us 4x, and 2 times 1 is 2. Second step is to collect like terms, so you should notice that 3x plus 4x equals 7x, and then we're left with 7x plus 2 equals 9, and now we need to get our variable by itself, so we're solving for x. So first of all, we take 2 from each side. Oops, that's cancelled out the wrong side. That line should be over the positive 2 and take 2, and sorry about that, and we end up with 7x equals 7. Divide each side by 7 to get x by itself, and we end up with x equals 1. Now, I'm running out of room on my PowerPoint, so you need to keep working down, but if you just keep copying this sentence below that x equals 1. So next we need to find y, so we substitute x equals 1 into the first equation, y equals 2x plus 1. We could have substituted it into equation 2, but equation 1 is easier. So y equals 2 times 1 plus 1, which equals 3. So the solution is 1, 3 for this set of linear equations. Again, you would need to check the solution by substituting the x value into each equation and ensuring that it equals the y coordinate. So you can do that yourself now and pause this workshop. Okay, third and final example. So in harder examples, when neither x or y is the subject, you need to use algebra to rearrange and make one of the pronumerals the subject of only one of the equations. So let's have a look at an example of this. So you need to copy down this sentence again and all of the working out. Example 3, solve this pair of equations for x and y. So with this set of linear equations, you'll notice that neither x equals or y equals it's by itself. So we have a bit of an issue that we can't directly substitute either equation into the other without a bit of algebra work to start off with. So let's label our equations again. We've got equation 1 and equation 2, and we're going to rearrange equation 1 to be in the form x equals and make x the subject. So here's our equation. Now the first thing we want to do is get x by itself, so we need to get rid of this minus 2y by doing the opposite and adding 2y to each side. Now, like I said before, there are various ways you could have done this to still get to that same solution. We could have used equation 1 to make y the subject, or vice versa, made x or y the subject of equation 2, and you will still get the same answer. So minus 2y plus 2y cancels out, and we're left with 3 equals 1 plus 2y. Now we need to get x by itself by doing the opposite of timesing by 3, which is dividing by 3. And you need to make sure that you divide each and every single term in the equation by 3. 3 over 3 cancels out, and we're left with our new linear equation, x equals 1/3 plus 2/3 y, and we now have an equation in the form of a subject, so x equals. So this is the equation that we're now going to be working with now. So we're going to label this equation, equation 3, so that we can explain our working out in our story of solving this equation. Okay, so now what we're going to do is substitute our new equation 3, which is in the form x equals, into equation 2. So you can see that I've just replaced that x with 1/3 plus 2/3 y. Okay, first step again is to expand the bracket, so 5 times 1 is 5 and 5 times 2 is 10. And now we need to collect like terms. But you'll notice that we've got 7y and minus 10/3 y. So we can't really add and subtract those fractions without making them the same. So there's various ways you can do this. I'm going to do a really simple way and just multiply both sides by 3. And that means I'm eliminating that denominator of 3. So I need to do times every single term on that left-hand side. So 7 times 3 is 21. 5/3 times 3 is 5, and 10/3 times 3 is 10, and then on the right hand side 2 times 3 is 6. Okay, now we can add and subtract our like terms. So I've got 21y take 10y is 11y. I need to get y by itself, so we add 5 to each side. That cancels out, and I'm left with 11y equals 11. I need to get y by itself, so the opposite of timesing by 11 is dividing by 11. And we're left with y equals 1. So now we need to substitute our known variable, which is y equals 1, back into any of our equations. So I'm just going to sub it back into equation 1. So 3x take 2 times 1 equals 1. And that simplifies to just 3x take 2 equals 1. We want to get x by itself. So we need to add 2 to each side. Minus 2 plus 2 cancels out. And we've got 3x equals 3. To get x by itself, we divide each side by 3. 3 over 3 cancels out because it equals 1. And we're left with x equals 1. So our solution for this set of linear equations is 1, 1, and again you need to check by substitution for those ones as well. So that's the end of our workshop for today. You can now start your exercises if you get up to it. All the best. Send me a Zuno message if you need any assistance so I can plan our lesson for Friday, and I will see you in class then. Thanks, bye.